Alright, let's begin. So for this video, we're going to talk about the scene management as well as the scene object and the camera management. So for the scene singleton, we have a way to define the start scene, get the current scene, set whatever the current 3D or 2D camera is supposed to be, define what the next scene is going to be, and end the current scene. And then we have some private functions that can be managed through an attorney. So we have the ability to change scenes, update, draw scenes, initialize the current scene, and unload the scene, or unload the scene manager specifically. Then we got the privates because we're doing a singleton, so some of the public functions will have their private instance versions. Then we have all the classes. So for the scene manager attorney, as I mentioned with the pass-throughs, we got the unload call in the kitchen. This unload, excuse me. This unload is called when the game is ended and we're unloading content. As for the other ones, we have the scene draw, scene update. Scene draw happens after visualizations and rendering, or screen log rendering specifically. Then we got the update here, and we have the initialized current scene here. So that's all the call throughs for there. Then we also have the scene change call through the attorney, which I will specify in a moment. So when we create our scene singleton, this is where we define everything. For this, the scene change, we have a strategy pattern set up. So there is the no op, which is our no scene change, is the no op. And then we have the scene change, which is where we execute the request and pass through the scene change call. So the scene change call here, scene change, we end whatever the current scene is, define the current scene to be whatever the user defined next scene is, initialize what is now the new current scene, set the next scene to null to make sure our assert for defining the next scene stays intact, and then we change our current scene strategy to be no scene change. So to go back up to here, we got a bunch of getters and setters. So we got the setting of the current scene, getting the current scene, setting the current 3D camera and 2D camera, as well as getting them as well. For setting the next scene, we assert that next scene is a null pointer. If this is not a null pointer, then that means we'll be leaking memory if we let them set the scene again. So we have to crash hard and fast to prevent that from happening. If this is a null pointer, then we just say the next scene is whatever the user is passing in, and we change our strategy to say there is a scene request. Initializing the current scene, we just take the current scene and initialize it. For the scene update, as we take our current scene change request strategy and execute the request. So as I mentioned, if it's the no scene change, it's a no op. If it's the scene change, then that's when we call that function from above. So when we call this function up here. After that, we call our scene manager. We call through the scene attorney the update call. We want to make sure that the scene that gets updated is the current active scene. So we have to make sure we check our change scene request first before we do the update. If we did this the other way around, then our new starting scene would be a frame behind, and that is not ideal. So we have to make sure we change the scene first, then call the update, which I will showcase soon. Scene draw, once again, we use the scene manager to pass through the draw call, and then we end the current scene. We call the end scene through our scene call, delete the current scene and set it to null, and then we unload all of our content. So unloading the content, we end the current scene, so we delete it. We delete all of our strategy pattern, we delete the next pointer, the next scene pointer, and then we delete the instance. Because most of the times the user is going to be creating new scenes without storing them. Like when we set the start scene, we just say new demo scene here. We don't have a variable to store it. It is our responsibility to make sure that that next scene is deleted. For the scene itself, we have the attorneys. Once again, this has all the pass-throughs that we were mentioning prior for the scene manager. So the way to pass through the current camera, the 3D or 2D, updating, draw, initialize, and ending scene. We also have the pass-through for submitting of requests for the game object and all of the exables for registry, deregistry, and requests. I will cover all of these in more detail in separate videos. The only thing of note is I did not have time to update to the new system of passing the manager through instead of having all of them individually in the attorney. So the collidable is a bit different. Other than that, we have a bunch of forward declares in our scene. We have the protected templatized function to help manage the collision pairs and the collision selves, which I will cover more in the collision video. Beyond that, we have the initialize and end scene for the user to define, registry and deregistry for each of the exables, the update call for the scene, the draw call for the scene, and the getting and setting of the 3D and 2D cameras. So in the scene.cbp, whenever a scene's created, we can create all of our managers. Initialize is an empty function for the user to define. We have the registry and deregistry for each of our exables, and then once again, the collision manager is a bit different. Then we submit the registration. We submit quests by pushing them onto the request broker. And to quickly clarify for the scene, because we're passing the collision manager, we can request registry and deregistry directly this way, rather than having to tell the scene to do the request of registry and deregistry. But in the update itself, at the start of each frame, we call in our request broker to process events. So at the start of each frame, we check to see if anything wishes to register or deregister to something, and we make sure at the start of the frame it happens so that they're not behind the frame. So if something wishes to be updatable, it will be updated the immediate next frame that it requested it. There will not be any delay in that. And if something wishes to no longer have inputs, once again, it will be at the start of the next frame, they can no longer accept inputs. After that, we go through all of our collisions, which is handled through a list. We go through all of our inputs, which once again is handled through a list. Go through all of our alarms, handled through a map instead. And for this one, we set it up as a map because we have multiple different alarms that can be registered to the same object. So we have to have it a bit more robust, which I will cover more with the alarm rules. And then we have the updates through a list. The next step would be to discuss the draw. So for the draw, we have one list, and we first go through all of the 3D objects, and then we go through all the 2D objects. We want to make sure all the 3D objects are rendered first, so that when it's time to render our sprites, they will appear in front of all the 3D objects. If we were to try and draw 3D objects and 2D objects at the same time, then some of the objects will start to appear on top of our sprites, which would be horrible for any HUDs that we wish to set up. Beyond that, we have the setting of the current 3D and 2D cameras, and scene is a function defined by the user, and then after that, we delete all of the managers. Speaking of managers, the last thing to discuss is the camera manager. So the camera manager, we have getters and setters for the 3D and 2D cameras, and then we have some default setups. So inside the class, we have the defining of the default 3D and default 2D cameras. We update the oriented position, update the camera, and set them to be the current camera, and then do the same thing for the 2D stuff. The user can choose to set whatever the current camera 3D or 2D is, as well as getting access to the 3D and 2D camera whenever they wish. However, when it comes to the destruction of the camera manager, we only delete the default 3D and default 2D camera. We do not touch the current 3D and current 2D camera, because if the user did not choose to define a new camera, so like if the user never defined a new 2D camera and we tried to delete the current 2D camera and the default 2D camera, we'd be deleting garbage memory and we would crash. So we make it up to the users to delete any cameras they ever choose to create. And that's it.